Good morning. Happy Friday. There are 8 of us here. I'm glad that we are here healthy and safe and sound, and I suspect that we'll have some folks trickling in. It's pretty slippery and slow out there. But yeah, I think this was kind of a surprise. Yeah. But we are here, and we're going to do what we were planning on doing, which is to talk about slope. So according to our calendar, this is lesson number 5. The homework for today's class is going to be due on Monday. And again, we're now in our rhythm where the homework assigned one day is always due the next class. The only exception to that is when we have a test or a quest. Now, quest is just basically a hybrid of the word quiz and test. What we have is something that's, say, bigger than a quiz and maybe smaller than a full-fledged test. So we call it a quest. Our very first quest is coming up on Wednesday, February 10th. The material covered on that particular quest is lessons 1 through 5. So how are you going to study? And it is not too early to start studying for this thing on Wednesday. How are you going to study? You are going to look at all of the My Math Lab homework. You're going to look at all the problems in the packet. That's the demos and the group activities, and you have even more practice in there, which I know that some of you have done, but it was optional. So if you're looking for more problems to practice on, you have them in the packet. And you've also got the practice problems packet, which, like I said when I handed it out, this is what I used to hand out as practice quests. I just took all the practice quest problems from the semester and smushed them together into one document. So the quest itself looks an awful lot like the problems in here. So if you are not taking advantage of this, I think you're missing an opportunity. It's totally optional, but you got to be able to use it. Yes, Joel. Yes, I'll get you one in a minute. Okay, and so the quest is on lessons 1 through 5. So on this first page, it tells you exactly which problems in this packet are the ones that are on lessons 1 through 5. Those are the ones you should be focusing on. I will point out that once we finish the stuff from today on slope, that is the end of the material for the quest. We are going to come in Monday and do something about equations of lines, but the Monday material is not going to be on Wednesday's quest. But I will also point out that we do not have a review day built in before that quest. So it is on you to figure out how to best study and prepare for that quest. And one nice thing about the practice problems packet is that I have made a YouTube video of me solving every single problem in this packet. And if you just read the directions here in this first paragraph, it will tell you how to find those YouTube videos. So even though we don't have this built-in review period, you have access to me solving all of these problems 24/7, any place that you can access the internet, okay? So not too early to start studying. That's coming up on Wednesday. Quest is the whole class period. Yeah, and also notice that there's no homework due on February 10th, right? That'll be the only time when we won't have homework due is on the day of a quest or a test. Okay, so we are here on the slope page, page 36. Let's give it a shot. In this lesson, we define the slope of a line, and we see several ways to calculate and use slope. First, our demo. A portion of road A, that's pictured here, climbs steadily for 120 feet over a horizontal distance of 4,250 feet. Everybody understand the picture? So you can imagine starting over here and finishing up here and driving along the road, and that road is going uphill, 120 feet vertically, 4,250 feet horizontally, okay? All right, then you've got another road not pictured, road B, which climbs steadily for 95 feet over a horizontal distance of 2,875 feet. And we're gonna try to figure out which road is steeper. So first, let's draw another diagram just like that one. But this one will be for road B. What number goes on the horizontal line of my triangle? Good. Somebody else, what are we putting on the vertical? 95. And the road itself is the diagonal line, okay? Now, answering this question, well, the answer to this question is not obvious. At least it's not obvious to me. Which road climbs more, just overall? A or B? A climbs more, right? Because it's 120 compared to 95. So how come it's not immediate that A is steeper? It's got more climb. What shorter distance? Yeah, A has more climb vertically, but it takes longer horizontally to do it than B does. And so you can't just look at the vertical numbers in isolation. We have to do something to the vertical and horizontal for A and compare to the vertical and horizontal for B. And so that's what we're after here. Let's see, this is a calculator active problem, one of the few for the semester. We're going to calculate the steepness of each line by finding the ratio, we saw that word the other day, that just means divide, of the vertical change to the horizontal change. Vertical change to the horizontal change. You could just as well do the ratio in the other order. We have reasons for wanting to do it in this order. Okay, calculation for A is done below. The steepness of A, we're just defining steepness to be the vertical change over the horizontal change, 120 over 4250. And if you type that into your calculator, you get about 0.028. Let's try the same thing for the steepness of B. Upstairs is the vertical change. What number is that? 95. Downstairs is the horizontal. 2875. Somebody with a calculator, 0.033. Okay, we've got two numbers. 0.028 is the quote steepness of road A. 0.033 is the steepness of road B. To figure out which one is steeper, it's still not obvious to me, but at least I have a single number for both lines as opposed to having two numbers for each line. And to figure out which one is steeper, I'm going to force this guy to be a fraction. Normally I wouldn't do this, but it's our first time doing this slope idea. So I'm just going to put them both over 1, which allows me to put some units on the fraction. The 120, was that a horizontal or a vertical? Vertical. So I'm going to say this is vertical feet upstairs. And downstairs with a 4250 was horizontal feet, yeah? So that means that road A climbs vertically 0.028 feet, which is not very much, for every 1 horizontal foot. That's what it means. Exactly the same units over here. Road B climbs 0.033 feet vertically for a 1 foot horizontal. The reason we can now compare these two single numbers, the 0.028 and the 0.033, is that they are both in relation to exactly the same horizontal change. Both of these roads have now been boiled down to, okay, what do you do when you move horizontally 1 foot? Which one of these rises more? It's B, right? Because 0.033 is a larger number than the 0.028. We're both running horizontally 1 foot. And the 0.033 is a slightly bigger rise than the 0.028. So then the 0.033 must be the bigger steepness. So here's our sentence, which is going to include both of those numbers. Since the steepness of B, 0.033, is greater than the steepness of A, 0.028, road B is steeper. Fair? Okay, so I'm going to try to say this as clearly as I feel comfortable saying it. We have a quest coming up on Wednesday. I really like this question comparing steepnesses of two roads. You hearing me? Yes? Yes? Okay. So to measure the steepness or slope, first time we're using this word today, it's just the word slope, but it's exactly what we did up there. We called it steepness. We're going to use the ratio that measures vertical change in the y-coordinate, which you can call the rise, to the horizontal change in the x-coordinate, which is often called the run. So it's the same calculation, vertical change always on top, horizontal change always on the bottom. Shorthand notation that defines slopes, that defines the slope uses the symbol capital delta, it's a Greek letter, which often represents a change in math and in science. We also use the letter M to stand for slope. So there are a lot of ways you could think about slope. Basically, the way that we thought of it up above was a change in y over a change in x. We didn't think x's and y's, but you guys know that vertical is our y change, right? And horizontal is a change in x. So let's actually see this formula, many versions of that formula in action here. Number 3, in a previous class, we graphed the equation y equals negative 200x plus 800. Showing the altitude y of a hot air balloon in feet, x minutes after releasing air from the balloon. You guys remember this question from an activity? So first we're going to choose any 2 points on that line. Now let's just all choose the same 2 points. I've written it out here for us. 0, 800, which is here. and 3 200, which is here. And so what we're going to do is calculate the slope of this line. It's already written, so we're just going to follow along. Slope, we'll always call it m. It is the change in y coordinates divided by the change in x coordinates. By how much do the y coordinates change, looking at these two numbers? How much? 600. Everybody agree? 200 to 800 represents a change of 600. By how much do the x coordinates change? 3. Going from 0 to 3 is a change of 3. But we just have to be, so it's a 600 is the vertical and a 3 is the horizontal. If I draw in these two things here, all of a sudden it becomes exactly like the road example. The vertical change was the 600, the horizontal change was 3. Right? It's exactly the same as the road. Jeff?
I was wondering why you put the triangle.
Mm-hmm. Okay. There? Take the one I did before, flip it which way? Oh. Like this? Oh, yeah. So we can't do it with this one because this one is going downhill. But it actually doesn't make any difference which of the graphs we draw. I could just as well have drawn this triangle here. It's still a vertical of 600 and a horizontal of 3, right? Okay, but we just have to be a tiny bit careful here because this line is going downhill as you go left to right. And so we've got formulas that we just have to follow. How did we get the 600? We did 800 minus 200, right? That's totally fine. 800 minus 200 is right there. But if we do 800 minus 200, subtracting in this order, 800 minus 200, notice the arrow, we have to be consistent and we have to subtract the x's in exactly the same order. So I was a bit careless when I said, how much is the horizontal? And everybody said 3. You were right, but I should not have asked the question that way. I should have said, how much is the change in x, but going in the same exact order that we did with the vertical. So we shouldn't have done 3 minus 0. We should have done 0 minus 3. And so that's what you see down here, 0 minus 3. Upstairs is the 600. Downstairs is the part that I kind of deceived you on. It should have been negative 3. And so when we simplify, we get negative 200. And that's what we call the slope of this line. Okay, so now what we are going to do is pick 2 other points on the line, not the ones that I've labeled in red. Somebody find me the coordinates of a point on this line. 1, 600. Everybody okay with that? So we're looking for nice points. So everybody grab a 1, 600, and then one more nice point on this line. 2, 400. Sounds good. So I'm going to leave this picture up here. You're going to go on the next page and start filling in the blanks. I've got all these fractions laid out for you at the top of the next page, but I want you to use the 2 points here. These coordinates are written in black. 1, 600, 2, 400. And actually write out the subtractions, even though you could subtract in your head, just write the subtractions on top, write the subtractions on the bottom, then do the subtractions and reduce if possible. Okay, upstairs, somebody tell me what the subtraction was. 600 minus 400. Did anybody write something different upstairs? Okay, so 1 minus 600 is a very common thing. Yeah, 1 minus 600. Anybody else? Yes? 800 minus 400. So you didn't use the 600 point.
No, I started.
Use the 800 point. No problem. Anybody write 400 minus 600? Yeah. So I'm gonna have 2 threads here. 400 minus 600 is another possible thing you can write. You just subtract. Doesn't matter how you subtract, but you got to be consistent. So the way that Casey has subtracted 600 minus 400, what goes downstairs is 1 minus 2. That is the right order. But the way that Jeff subtracted he would have done 2 minus 1, which looks different. 600 minus 400 here is a 200 over negative 1, which is negative 200. Let's take a look at Jeff's calculation. Upstairs is a negative 200, that's different, divided by downstairs is a positive 1, that's also different, but when all is said and done, same answer. So, two things to take away from this. Number one, it makes no difference which 2 points you pick, because we got negative 200 on the previous page with 2 completely different points. It makes no difference which points you pick. The slope of a line is just consistent. It is what it is. It's just for us to calculate. Number two, it doesn't matter how you subtract as long as you are consistent on the top and the bottom. And so you have choices here, but you got to be consistent. Let's talk about this 1 minus 600. Where did we get that? Yeah, I mean 1 and 600, that was one of our points, wasn't it? And it's really natural. We know we're going to be subtracting. We've got 4 numbers. Subtracting these 2 is a natural thing to do. It's a common mistake. But we got to make sure we are subtracting not the coordinates of the same point, but rather the y from the point and the y from the other point. Always subtracting the y's and then separately subtracting the x's. Okay. All right, so let's go down to part F. What does the slope mean in this situation? Let's first write down the units. So the first calculation we did on the previous page, it was a change of 600, but that was 600 feet, right? This was the altitude of the balloon that we were subtracting. And downstairs was -3, and it was minutes. This was time in minutes. And so that -200, the units are just feet on top and minutes on the bottom, feet per minute. And so once you've got the units written down, that -200 feet per minute, you just change the division line to the word per in your head, the sentence is just about written. So we just have to pad it a little bit with some words. So with the units written down, it's fairly straightforward to write a sentence in plain English explaining the significance of the slope. We've got 3 versions of the sentence. All 3 versions are full credit answers. Good sentence. The balloon's altitude was changing at -200 feet per minute. -200 feet per minute. Just get the units in there. A better sentence. The balloon's altitude was decreasing at 200 feet per minute. I made 2 changes there. The word changing became decreasing, but what was the other change? -200 became 200, right? The word decreasing, the negative means decreasing. So either of these is okay. I like the second version better, but what I don't like, and which will lose points, is decreasing at -200, because that's redundant. If you say decreasing, you have taken care of the negative. And then even better, the balloon was falling at 200 feet per minute. Like I said, all 3 of these are full credit answers. We're just looking for plain English sentences. A plain English sentence should not have the word slope in it. You ask your average Joe on the street what slope is, and they probably won't know. These are things that the average Joe on the street could understand, right? Okay, a couple of common pitfalls. I think we mentioned these before. Part B, anyway, we mentioned. You have to be consistent in the order that you subtract in the numerator and denominator. Part A we haven't talked about, but the slope is the change in y over the change in x and not the other way around. It is always y on top, it is always x on the bottom, and it is always easy to reverse those and put x on top and y on the bottom. And if you do, you'll get the thing wrong. A couple of semesters ago, somebody said something like, I don't know why y goes on top, and that was how he remembered that y goes on top. He just said to himself, I don't know why y goes on top. Okay, the activity starts on the next page. And I will walk around and help. Again, a reminder, you are not using your calculator on any of these problems.